Okay, welcome back. This is Mr. Wakefield here. This is the second half of, or part two rather, of section 1.7. We did quadratic inequalities in the previous video in section 1.7, as you can see here. Now we're going to look at rational inequalities. Rational inequalities is just the same thing as saying that it's a fraction inequality. The word rational, in this particular case anyway, is referring to when you have a fraction with the polynomial on the top and the bottom. So notice that we have that in both of these problems right here, 1 and 2. Okay, a fraction with the polynomial on the top and bottom of the fraction. And so when you have that type of fraction inside of your inequality, and you can see these are inequalities, they both have the inequality symbols there, greater than or equal to. Okay, you could also see less than or equal to as well. But these are inequalities that have a rational expression in them, thus a rational inequality. How do we solve those things? Well, it's a little bit different than the quadratic ones that we saw in the previous video. Okay, what you need to do, and notice in the first problem, the first two steps are already done, okay, but not in the second problem. The first two steps say write all the terms on one side of the inequality, which would then make the other side equal to 0. Okay, you can see that's already the case here. We have a 0 on one side, so everything else is on the other side. That's what the first step is telling us to do. It's already done. Speaking of that, the second step is also done. It says write the non-zero side as a single fraction. In other words, don't have a fraction and then some other stuff on that side. If you do, then you need to condense it down to a single fraction. I will show you how to do that in the next problem because that will be an issue there. But here it's already done. We have a single fraction. So single fraction on one side, 0 on the other side, inequality. That's what the first two steps want. So we can jump right to the third step here on the first problem. Second problem will be different, but on the first problem we can. Here's what you do. Instead of factoring and all that stuff like we did with the quadratic inequalities, once you get the single fraction on one side and the 0 on the other, you take the numerator, you set it equal to 0, and you take the denominator and you set it equal to 0, and that's going to be your boundary points. Remember in the last video we said that we had the two boundary points here we set those things equal to 0. We solve. We got 0 and 4. Over here we got -5, -1/3, and those are the numbers you put on the number line. Okay? Same thing here. It's just that you do it. You find those two numbers in a different way. You set the numerator and denominator equal to 0. If I do that and I solve these resulting linear equations by subtracting the 5 over and adding the 2 over, I get -5 and +2. From here on out, it's pretty much the same thing, you guys, all right, as what the previous video was. You take the two numbers, always put the smaller number on the left, bigger number on the right. It breaks it up into 3 intervals again, okay, and you test out each one. How do you test out each one? Just like we did in the last video, you take the inequality, okay, not the equations, but the inequality, okay, and you plug the any number you want inside of each interval in there. Okay, so any number between -infinity and -5. How about -6? Just to pick one. Just like we did in the last video with the quadratics. Okay, just a reminder, you guys, when you have, because we need to do order of operations right now, we need to figure out what each side is equal to. Okay, when you do order of operations with just a single fraction, what you do is you figure out what the top and bottom are equal to separately. Okay, don't try to combine the top and bottom together. Don't do any canceling, okay? Not here, okay? There's no variables here. Not that you couldn't cancel when there's no variables, but we don't want to do that here, mainly because of the plus and the minus here. And again, without getting into a big discussion about canceling here right now, because that's not really important here, the plus and minus is a big reason why you can't cancel. But again, don't need to get into that discussion right now. Just remember this, all right? All we want to know is what the top and bottom are equal to. So canceling is not necessary. Just figure out what the top is and figure out what the bottom is separately. Okay, no canceling needed, and in this case, it wouldn't be allowed. So the top is equal to -1, isn't it? The bottom is equal to -8. Now, how do I know what if this fraction is greater than 0? Okay, remember, you guys, when you have a fraction and you have a 0 on the other side, that's one of the reasons why we want to have a 0 on the other side. It makes it a lot easier when 0 is on one side, because here's the thing. If you have 0 on one side of your inequality, if this is positive, it's always going to be true, because positive is always greater than 0. It'd be different if it said less than, but it says greater than, okay? Positive is always greater than 0. If this had been a negative fraction, then that would not be greater than 0. But it doesn't matter what fraction it is. The only thing that matters is it positive or is it negative? Now, when you have a single number on the top and bottom of your fraction, no additional terms, no pluses or minuses, okay, in between terms, just two numbers, one on top, one on the bottom, okay, the signs tell you what the overall fraction is equal to. Negative divided by negative is positive, isn't it? Okay, because this is a positive fraction, then it must be true. Okay. That's the thing, though, you guys. Negative divided by negative is positive, okay? If there had just been one negative, okay, for example, if it had been negative divided by positive, or if it had been positive divided by negative, then the whole fraction would be a negative, and then it would be false because it's not greater than 0 then. We'll see that coming up here. But because that's positive, okay, that's positive overall because it's negative divided by negative. All right, that's what makes it true. Positive is always greater than 0. Okay. Let's try the next one here. 0 is in between -5 and 2, isn't it? So I'm going to plug in 0. Is this greater than 0 here when I plug that in? Figure out what the top and bottom are equal to. And notice here, you guys, we have we have a positive divided by a negative. Again, if you just have a single number on the top and the bottom, the signs will tell you what the sign of the overall fraction is. If you have a positive divided by a negative, that is a negative answer, isn't it? And a negative answer is not greater than 0. And it doesn't matter what that fraction is equal to. Like, you could put this in your calculator and it would say -2.5. But you don't even need to do that. You just know that it's negative, and that's all that you need to know, because any negative number is not going to be greater than 0. That would always be false when you get a negative greater than 0. Always. So you don't even care that it's -2.5. What you care about is the fact that it's negative. The negative part is all that you need to know when you have a 0 on the other side. If there was something other than 0 on the other side, then it's a little bit different. We'll get into that more here as we go on to the next problem. But when you got that 0 on the other side, the sign of the fraction is really all that needs to be known. Because 0 is that number that's between the positives and negatives, right? Okay. All negatives are less than 0. All positives are greater than 0, okay, without exception. So the number is not important, it's the sign, positive or negative, that's important. Positive divided by positive is positive, isn't it? That's positive right there. Positive is always greater than 0, so that, again, we don't even care what 8 divided by 1 is. Yeah, we know that it's equal to 8. 8 divided by 1 is 8. But even if you didn't know what it was, you would still know that this is true, because positive is always greater than 0. Sorry, I forgot to start shading there, you guys. All right, we know, though, from the last video that whenever it's true on these intervals, we are going to shade, and when it's false, like it is in the middle interval there, we don't shade. We leave that empty. And so there we go. Now, what do we do as far as the brackets? Remember, we got to do a bracket, either round or square bracket, when you have a shading on one side of a number, but not on the other side. We can see that that's true here with both -5 and with the 2. Okay. What bracket are we going to use? Well, because this is greater than, and it doesn't have the equal to, all right, that automatically means that this is round and round, right? Just like we said in the previous video. And so we have round brackets on both of those. All right. Now, how do we do the interval notation? Now that we've done the shading and the brackets, we're now ready to do the interval notation that they ask for in the directions. Okay, but make sure you get all the number line done first so you can clearly see what interval notation you need to write down. Okay, we can see now that we need to write down negative infinity because that's where the shading starts. Put a comma until the shading ends. The shading ends at -5. So write down that. Remember, negative infinity is always round. You got to have a bracket next to each number in the interval notation. Remember, that's why I'm doing brackets next to each number. The -5 is round because the number line tells us that. Okay, the negative infinity is always round, so we don't need the number line to tell us that. Remember, we said in the last video that when a shading stops, is blank for a while, and then the shading starts back up again, we put a U there. Yes, the U needs to be there. That's mandatory. Okay. And then it starts back up at 2, and it goes all the way to infinity. Infinity is always round, and then because the number line told us so, the 2 also has a round bracket next to it. And there you go. All right, so a lot of similarities between this, between these rational inequalities and the quadratic inequalities. Okay. Now, this next problem is going to be very similar, at least in the second half of the problem. But as I was kind of hinting at before, all right, we need to have a single fraction on one side, but we need a 0 on the other side. Because this is not 0, that creates a whole different situation. Okay, so how do you take the 2 and make it into a 0? A lot of you are probably thinking, hey, why don't we just subtract the 2 over? That is the correct way to do it. You need to subtract the 2 over, so it's going to look like this. Now, I know some of you are thinking of some other ideas. Okay, let's talk about that. All right, this is the right way to do it. Why is that the right way to do it and the other ways are wrong? Well, it depends on what you're saying. This is the way we're going to do it, though. But there are other things that people think about sometimes that are wrong, and I want to make sure you know why they're wrong. Okay? Some people will look at this and say, hey, that's kind of like those problems we did a few videos ago where we got a fraction, and why don't we multiply both sides of the equation by the LCD? Well, here's the problem with that, okay? You don't want to do that with inequalities. You can do that with equations. This is not an equation because an equation has an equal sign. Okay, when you have an inequality, okay, with the inequality symbol, greater than or less than, those kinds of things, all right, that's a different story. Let me tell you why. Looking back at reviewing again in the prerequisite review packet, it mentions when we have first learned about inequalities with the linear inequalities, and this also applies with all inequalities though, all of them, is that if you multiply or divide both sides of an inequality by a negative number, you must flip or switch the direction of the inequality symbol. In other words, greater than would have to be flipped around and become less than. Here's the problem, though. What if I multiply or divide both sides of an inequality by a positive number? Then you don't flip it. Okay? So if you multiply by a negative on both sides, you flip it. If you multiply by a positive, you don't. Here's the issue. Sometimes you flip it, sometimes you don't, right? The LCD here is x minus 1. X minus 1 has a variable in it. Because it has a variable in it, we don't know if it's positive or negative. It all depends on what the x is equal to. Since we don't know what x is, since it's a variable, we don't know if we're multiplying by a positive, which would not make the inequality symbol flip, or if we're multiplying by a negative, which would make it flip. And so therefore, we're stuck as far as that method is concerned. We can't do that because we don't know if we're supposed to flip it or not. By the way, we talked about cross-multiplying a few videos back as well. You can't do that here either for similar reasons. Okay? because that's closely related to multiplying by the LCD, even though it's not quite the same. It has a similar effect. Okay. Similar issues that happen with that as far as what is greater than, what is less than, what direction does the inequality go, what does it go towards, all right? So without getting into all of those details, all right, just please remember, here's what you need to remember. When you have a single fraction on one side, but you don't have a zero on the other side like we did here, okay, the only way to do it, okay, I mean, there are other ways that it can be done, but they are more complicated is what I'll say. So that's why we're gonna do it this way and this way only. The really best way to do it, let's put it that way, the really best way to do it is to subtract this term over, which would then make this a zero here. 2 minus 2 is 0. So that's the way that I need you to do it. Okay. The other way, like I said, there are other ways it would work, but it's best to just not get into that because they are kind of complicated as far as, sometimes they work, sometimes they don't, kind of stuff. All right. So this is the way we're going to do it. Okay. So we got the 0, right? We needed the 0. But now this is not a single fraction anymore. We need to make it into a single fraction, and we can. So you move that term over, you got the 0 that you wanted, but you need to make this into a single fraction. Now, how do we do that? Well, whenever you have a fraction, you guys, and it doesn't matter if this is addition or subtraction, okay, either way, what you need to do is you need to make this thing into a fraction also. And little review here, whenever you add and subtract fractions, what do you got to do in order to combine these into a single fraction right here? You need to actually go through the process of subtracting the fractions, which means to get a common denominator. Don't worry, the problem we're doing right now is a lot simpler than this one. I'm just showing you this example, okay, because it's in the prerequisite review packet. But it reminds us here, this example, that we need to get the same denominator. See how the denominators are the same? Then you combine the numerators together and keep the denominator the same. See how the denominator stayed the same? X minus 2x plus 5 on both of these, and then it stayed the same down here. Okay, and then we did this one additional step here, but you don't need to do that in this particular example. Don't worry. Okay, so we need a common denominator. Okay, we need to figure out the LCD. And whenever you have two fractions, and one of the fractions has 1 as its denominator, I promise you, 100% of the time, the other denominator will be your LCD automatically. So here's what we do. I'm going to do this off to the side here. I am going to make both of the denominators equal to the LCD. That's what you got to do when you add and subtract fractions. In this case, we're subtracting the fractions. How do we make both of those equal to x minus 1? Well, the first one already is x minus 1, so as they say, if it ain't broken, don't fix it, right? Okay, this has already got the LCD inside the denominator, so keep it the same. Don't change it. This one, however, does not. Okay, so you got to figure out 1 times what? You got to multiply by something to make it equal to x minus 1 on the bottom here. But whenever you multiply by 1, okay, you just multiply by the same thing that this is equal to, okay, and it'll give you x minus 1. So if this had been equal to 8 right here, you'd say 1 times 8. If this had been equal to 10, you'd say 1 times 10. But since it's x minus 1, you say 1 times x minus 1. Remember, when you add and subtract fractions, when you're making the denominator the same, you got to multiply the top and the bottom by the same thing. But that minus sign can be a little tricky. We kind of saw this with the fraction equations as well. What I need you to do, okay, is... and I'm not saying this is the only way to do it, don't get me wrong, but just it's easier to avoid mistakes, is don't multiply by -2 here. Just multiply by the 2, and then we'll talk about the minus after that. So if you distribute the 2, okay, you get 2x minus 2. Don't worry, I'm not done yet. Okay, you distribute the 2, so when you're subtracting fractions, ignore the minus sign until you're ready to subtract the numerators. We had to multiply this out first. That has to be distributed out. You cannot leave that bracket there, okay, because of what we're going to do next. We need to combine like terms, so we can't have brackets. All right, so you got to distribute out the bracket to get rid of it. Now, here's the thing. If you don't remember this, okay, in the prerequisite review packet, it reminds us that after you get rid of the parentheses here, all right, what happens is that because we're subtracting, you need to change the signs of all the terms in the second numerator. Okay, so we make the denominators the same. We did that. We multiply the top by the appropriate thing. Here we didn't have to do it. Here we did. Okay, we multiply by the appropriate thing, get rid of the parentheses on the top. Then you gotta change the signs before you combine like terms. Okay, the subtraction means you got to change the signs on the second numerator. If it was addition, you wouldn't have to do that, but because it's subtraction, you have to. So that makes this what? It makes this -2 instead of +2, and it makes this one +2 instead of -2. Okay, so make the denominators the same. Get rid of the parentheses in the numerators if you have any. And then if it's subtraction, if you're subtracting the fractions, change those signs before you combine like terms. Now I'm going to combine like terms because I changed the signs of, you're just changing the signs of the second numerator, not the first one, so we don't make this -x. Okay, it's just the numerator that you're subtracting. So it's x minus this numerator, so it's this one that you change the signs on, that numerator. Now I combine like terms and I get this right here. -x plus 2. And what did we say earlier when we subtract fractions? That once the denominator is the same, it stays the same. And we did it, you guys. We took these two fractions right here and we combined them into one fraction, which is what we needed to do. We need to have that single fraction, just like in problem number 1. We needed a single fraction on one side with a 0 on the other. We did it. This now looks like, I know it took a lot of work, but this now looks like that. Single fraction on one side, 0 on the other. Okay? So now what do we do? Now that because it's an inequality, okay, with the single fraction and then the 0, we do that thing like we did in problem number 1 where we set the numerator equal to 0. We set the denominator equal to 0. And we solve those resulting linear equations that we get. If I add the x to both sides here, you could subtract the 2 as well. It's going to come out the same in the end. But this is one less step if you do it this way. But you can do it either way. So we end up with 2 equal to x. X is by itself. And then this one, x equal to 1. So 1 and 2 are the two numbers that we get this time. 1 is smaller than 2, so I'll put that on the left. Okay. Break this again up into 3 intervals. Now you notice this time that we have 2 different inequalities here. We got the original one with the inequality symbol, and then we got this one down here, and we got this one in between as well. But the point is you got more than one inequality. Which one do you want to plug it into? You can plug it into pretty much any inequality, any one of these 3 anyway. Okay. Make sure that these are equal signs, though. Okay, I want to be careful when I say that. When I say any inequality you want, make sure you don't make these into an inequality. Okay, don't have the inequality symbols here because you can't plug it into those. Okay, that will give you the wrong answer. But it could be let's put it this way: if you could either plug it into the original one or the one where you got the single fraction and then the 0. Either one of those two. Yes, you could plug it into this one as well, but I'm just trying to make things as simple as possible for you here. Okay, you can plug it into the original one or the one where we got the single fraction and the 0. Okay, let's keep it simple and just focus on those two things. Your choice. But as I said in the last problem, you guys, when you have a 0 on one side, it makes it easier to figure out the answer. Because when you have a 0 on one side, okay, all you need to know is the sign of this in order to know what the answer is. You don't even need to know what the fraction is equal to. You just need to know what the sign of the fraction is. Okay, and so that's what I like to do, but you are welcome to plug it into the original one as well. It'll give you the same answer. It's just a little bit tougher to work with. Single fraction, 0. If you plug it into that one, it's easier. So let's start plugging in some numbers. Negative infinity all the way up to 1. Pick a number in between. How about 0? So if I plug that in, and I'm going to plug it into this one, like I said, negative 0 plus 2. And then 0 minus 1 underneath that. Is that greater than or equal to 0? Okay, remember when you have negative and then x, that means negative 1 times x. So this is negative 1 times 0, which is 0. And then 0 plus 2 is 2. Down here we just have 0 minus 1 is negative 1. Now, remember what we said. Positive divided by negative, just like this one up here. Okay, that's negative, isn't it? Is a negative number greater than or equal to 0? No, it is not. Okay, it's less than 0. And so that is going to be false. What does false mean on a number line, you guys? It means do not shade it, right? Okay, I got a little bit of a tougher one here. Between 1 and 2, all we got are decimals and fractions, right? We don't have like a normal whole number, right? So I'll just do the best I can here. I'll do 1.5. You could do 1.4, 1.3, whatever you want to do. Okay. So I'll plug that in. Just got to work a little bit harder now because we got a decimal instead of a normal whole number. You can use your calculator to help you out here. So negative 1 times 1.5 is negative 1.5, right? What's negative 1.5 plus 2? Again, you can use your calculator there. That would be 0.5 positive. Underneath that, we have 1.5 minus 1. Again, you can use your calculator there if you need help on that. And that would be 0.5 as well. Positive divided by positive is positive. And you might already know what that fraction is equal to anyway, but we just need to know the sign when you have a 0 on the other side. Positive numbers are always what? They are always greater than or equal to 0 every single time. And so that's true. The sign is all we needed to know, okay, in order to know that that was greater than or equal to 0. Last one here, how about we plug in a 3? If I plug in a 3, I get negative 3 plus 2 divided by 3 minus 1. Again, plug it into this one here. And we get negative 1 times 3 is negative 3. Negative 3 plus 2 is negative 1. Okay. Remember, you need to do the multiplication before the addition. That's why I did it that way. 3 minus 1 is 2. Multiplication always comes before addition. And so negative divided by positive is negative. Remember, when you have just a single number on the top and bottom of the fraction, and that's all you have, that means that if one is negative and one is positive, doesn't matter where the negative is, that's going to be a negative answer. And a negative number is never greater than or equal to 0, so that's definitely got to be false. We don't even care what the fraction is equal to. We just know it's negative, and we know that negative can never be greater than or equal to 0. So since it's false, I'm going to leave this blank. And once we do all of our shadings, then what do? We determine what our brackets are. Now, this is that special exception that I was talking about in the previous video. I mentioned that. I said in the previous video that whenever you have an inequality with no equal to underneath it, it's always round, right? And then when you have an inequality with the equal to underneath it, it's always a square bracket. And then the infinity and negative infinity, those are always round. But I'm talking about the regular non-infinity numbers, okay? Round when you don't have the equal to underneath. Square, okay? And we saw that in the previous video, square when you do have the equal to underneath, okay? But there's one exception to that. Okay, as we mentioned in the fraction equation video, when you have a 0 denominator, that number can't be a solution. It just cannot. It does not matter what the inequality symbol is. If you have a zero denominator, that number that makes the denominator equal to 0 cannot be a solution. The 1 makes the denominator equal to 0 if I plug it into there. So here's the thing. The number that makes the denominator equal to 0, the number that makes the denominator equal to 0 is always going to be a round bracket. Always. Okay, and I've got that written down up here, so you don't need to write it down. Remember that the numbers that make the denominator equal to 0 will not be in the solution set no matter what the inequality sign is. And because they're not in the solution set, then as we said, that means that it's going to be a round bracket for that number. Okay, because the round bracket means that it's not a solution. The square bracket means that it is. So even though this is got the equal to thing underneath it, okay, the 1, because it makes the denominator equal to 0, that's always going to be round, irregardless of whether or not you got the equal to sign or not underneath the inequality. Now, in all other cases, okay, not talking about infinity and negative infinity, I'm just talking about the regular numbers. In all other cases with inequalities, all right, that you follow that rule where the equal to thing means it's square bracket, and not having the equal to thing underneath here means that it's round. In all other cases, so for that reason, you guys, because the 2 does not make the denominator equal to 0, it follows the normal rule. So the only time that you have the special exception is when one of these problems where you have a denominator and whatever number on the 2 numbers that you put on the number line, whichever one of those 2 numbers makes the denominator equal to 0, that's the one that you make round. But everything else follows the normal rules. Now you might be wondering, why didn't I do that here? It's because it was already going to be round anyway because there's no equal sign. Okay, and so notice here that the 2 makes the denominator equal to 0, all right? And so, yes, it's round for that reason, but it was going to be round anyway because this thing does not have the equal to thing underneath it. Okay, so the fact that the fact that I didn't say anything about the special exception here, that's because it was going to be round anyway, so I didn't need to. Okay. Just know that it's always going to be round if the number makes the denominator equal to 0. But because this thing didn't have the equal to thing in it, it was going to be round anyway. So there was no need to even consider the situation with the 0 denominator because it was going to be round anyway. And so we were going to get the right answer either way. But when you have the equal to thing underneath the inequality, you got to be careful. You got to look closely at what the denominator is gonna, what number is gonna make that denominator equal to 0. It's 1, and that's the one you got to be careful with because normally you just make your bracket square when you have the equal to thing here, right? Okay, but with a 0 denominator, it's always round. So 1 makes this, the number 1, when you plug it in, it's going to make this equal to 0. And so that's why I made that round, even though that's got the equal sign. But over here, even though the 2 made the denominator equal to 0 here, okay, it was going to be round anyway. But if it hadn't been round, but if this had an equal sign here, you'd still make that round. Because the number that makes the denominator equal to 0 will always be round no matter what. Okay? When you're doing the number line, all right? It will always have that round bracket. Okay, so now that we've done the number line, we've done the shading, we've done the brackets, we're now ready for the interval notation. The shading starts at 1 and it ends at 2, so put that comma in between where it starts and where it ends. Okay, and then do your brackets. As you can see in the number line, the round bracket is with the 1 and the square bracket's with the 2, so you just have to use the same brackets right there. And there's not more than one shading here, and so that's all you got to write. Okay. So that concludes the rational inequalities. I like to call them fraction inequalities as well. Okay, but that concludes that discussion and also concludes 1.7 as a whole. In the next video, we will start Chapter 2. In the meantime, though, please don't hesitate to let me know if you have any questions. You can visit me in my office hours or send me a message, no problem. So you have a good day, take care, and we'll see you back here for the beginning of Chapter 2 in the next video.